Hello, welcome to another video in the SaMi pre-AMC lecture series. I'm Olivia, and let's get started with today's things. So we want to know how many distinct triangles can be drawn using 3 of the dots below as vertices. Alright, let's draw some things out. We're going to try to be organized, right? So I'm going to classify some types of triangles. Start with this type of triangle, where two ends go one across, and the other one is the hypotenuse that goes sideways across. So we got like that, like this, like this. So those are those ones, and then that's 4 so far. And then we can also go like this, like this, like this, like this. So that's 8 triangles that look like that. What else could we do? We could go across like this, which is the same as if we crossed it over like this. So that adds 4 more triangles. Okay, we've also got triangles that look like this, and the opposite, which adds 2. And we could also go across like this, which would be the same as going across like this, and then flip it also, so that adds another 4. And so that's 18. That's all of our pictures. That's answer choice C. Okay. A company sells detergent in 3 different sized boxes. We've got small, medium, and large. The medium size contains 50% more than the small and contains 20% less detergent than the small. The large size contains twice as much detergent as the small size and costs 30% more than the medium size. Rank the 3 sizes from best to worst by. Alright, let's set some prices arbitrarily. Let's say the medium or the small, let's say that's $10. So one way to solve this problem is just to set, if you don't have any values, you just set a value and you go with it. Right? So we've got the medium is 10, and we'll say it's got 10 ounces of detergent. Okay. So the medium size costs 50% more. So it's 50% more than $10. So what's 50% of 10? 50% is half. So that's half of 10 is 5. And it's 50% more, so it's an extra $5. Right? 50% more, half of 10 more. 10 plus 5, $15. Okay? Medium size costs 15 and contains 20% less detergent than the large size. The large size. Okay. The large size contains twice as much detergent as the small size. So large size has twice as much detergent as the small size. Small has 10, large would then have 20, twice as much as 20. And costs 30% more than the medium size. Remember, the medium size costs $15. So how much would the large size cost? Well, we want 30% more. 30% of 15 is 15 times 0.3. That's an extra $4.5. So the large one costs 15 plus $4.5. That's $19.50. Okay. And now we can go back to the medium. It has 20% less detergent than the large size. So the large size has 20 ounces of detergent. We're going to do 20 times 0.8, right? Because we've got 20% less. So it's going to have 0.8. That is 16 ounces of detergent. So $15 and has 16 ounces of detergent. Okay. So let's look at what's the best deal. The small one, it costs the same amount as it has detergent. The medium one, there's more detergent than the cost. And the large one, there's also more detergent than the cost, but they're pretty close. So this is a difference of 1/2. This is a difference of 1. So the medium one has more detergent per cost than the large one does. So our medium, because of the more detergent per cost, the medium is the best deal, and then the large, and then the small, right? Because at least with the large, you're getting more detergent than you're paying money for, and with the small, it's the same. So we have medium, large, small. Answer choice B. We have an isosceles right triangle, encloses a semicircle of area 2 pi. The circle has its center at O on the hypotenuse of AB, and its tangent to sides AC and BC. What is the area of the triangle ABC? We can see that this circle crosses the triangle in the middle, right? And the semicircle is area 2 pi. And our area of the semicircle is going to be radius squared times pi divided by 2, right? Because it's a semicircle, so we only take half of the circle's area. And that equals 2 pi. Okay, using that, we can solve for the radius. So, in this case, we've got radius squared times pi is going to equal 4 pi. Dividing both sides by pi, radius squared equals 4. So our radius is 2. This distance is 2. Okay, so now we see that our triangle, halfway across and halfway across, this is length 2 and 2. Right? So this other half is also 2, and this other half is also 2. So now we've got a triangle with two sides that equal 4. So what's the area of our triangle? It's going to be base times height divided by 2. 4 times 4 is 16. Divided by 2 is 8. Answer choice B. Okay, we've got a calculator with only the keys +1 and ×2. We want to get from 1, ... all the way to 200. So let's think about the fastest way to do that. Well, let's say, how would we want to get from the step before 200 to 200, right? So let's work backwards. So before 200, we can be at 100 and then press the ×2 key, right? We can skip all the way from 100 to 200. That seems like the fastest way from there. Okay, that's pretty easy because I wouldn't want to do 100 plus 1 plus 1 plus 1. So this makes that simpler. Okay, then what about working from 100? If you're at 100, we can also do the ×2 key from the step before. So we could say we're at 50, and then we press the ×2 key, and then we end up at 100. Okay, so in 2 steps there, you could get from 50 to 200. That's a pretty good deal. We could also do the ×2 key to the step before 50, right? We could get 25 times 2 and get to 50. All right, that's pretty good. Okay, but from 25, we can't have used the ×2 key before then, because 25 is an odd number, right? So there couldn't have been a ×2 if we're working with an odd number. So it must have been the +1 key we used. So we'd have gone from 24. Okay, well, from 24, we could have used the ×2 key, right? We could have done 12 times 2 is 24. And we could do the ×2 key to get to 12 also, right? 6 times 2 is 12. Again, ×2 key to get to 6. We can do 3 times 2 is 6. Alright, so how do we get to 3? Well, it can't have been the ×2 key, right? Because 3 is odd. So you can't multiply an integer by 2 and get to 3. So it must have been the +1. So we must have gotten there from 2. Now, it doesn't really matter how you get from 1 to 2. You can either +1 or ×2. It's the same either way. Let's say we did +1. So here's our fastest path. 1 to 2 to 3 to 6 to 12 to 24 to 25 to 50 to 100 to 200. Okay, how many keystrokes does that take? Here's one keystroke, the +1, another for +1, +2, that's 4, 5, 6, 7, 8, 9 keystrokes. Answer choice B. A square with side length 2. They share a common center with a circle. We want to find, the total area of the region inside the circle and outside the square is equal to the area of the region that are outside the circle and inside the square. So what is that saying? Outside the square, inside circle but outside square. So that's this, 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 this. That's equal to this, 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 this. And we want to know the radius of the circle. Okay, so we know, let's look at the circle. So the inside of the circle, the part here that's both circle and square, that part plus our circle bits here, so plus all those circle bits, that's going to equal, let's look at our square. The square has this inside plus all of the lines that come out, all of these lines, right? So the area of the two shapes, the area of the square and the area of the circle, are actually the same. Okay. We know the square has side length 2. That means its area is 4. Okay? And that's the same as the area of the circle. Remember, for a circle, area is radius squared times pi. Our circle has area 4. So solving for the radius squared equals 4 over pi. Radius equals 2 over the square root of pi. That's the 2 over the square root of pi. And that's answer choice A. Mindy made 3 purchases. What was her total to the nearest dollar? So basically, we just need to add up these 3 sums, right? Her total is going to be the amount she spent for each thing. All right, adding that up. Make sure to line up your decimal places. $16.91. We want to round that to the nearest dollar. 91 cents is rounding up, right? We're rounding up because we have 91 cents. So our answer is D, 17. 16.91 rounds up to 17. Okay. Billy answers 13 questions correct, 7 incorrect, and doesn't answer the last 5. What is his score? All right. Let's see. How do they score the AMC 8 test? That's pretty bad that I don't know. So let's see. Okay, so according to my Google search, you get 1 point for a correct answer on the AMC 8. And nope. According to my Google search, you get 1 point for a correct answer on the AMC 8, and you're not penalized for an incorrect answer. So that's nice. I'm only used to taking not the AMC 8, so this is a lot better. It's a better deal, I'd say. So, for 13 questions correct, Billy would get a score of 13. Answer choice C. This is a good way to make sure you know the test you're taking. Okay. Eliza swims laps in the pool. When she first started, she completed 10 laps in 25 minutes. Now she can finish 12 laps in 24 minutes. By how many minutes has she improved her lap time? Okay, so basically this is saying, how long does it take her to do a lap? Okay, when she did 10 laps in 25 minutes, you do 25 divided by 10, it takes her 2.5 minutes per lap. That was when she started. Now she can finish 12 laps in 24 minutes. So how long does it take her to do a lap? We've got 24 minutes divided by 12 laps. She can do 1 lap in 2 minutes. So before it took her 2.5 minutes, now it takes her 2 minutes. So she's improved her lap time by 2.5 minus 2. That's half a minute. Answer choice A. Okay, we've got a spinner that points west. And then it's been moved clockwise 2 1/4 revolutions. And then counterclockwise 3 3/4 revolutions. So what direction does the spinner point after the 2 moves? So originally it points this way. So something to notice is that after one revolution, the spinner is back to where it started, right? So if you spin it around once, whoop, it's just going to end up facing this way again. So in 2¼ revolutions, we only need to pay attention to the quarter part. That's the only part that's going to have the spinner end up in a different position. Okay? Remember, clockwise is this direction. So 1/4 of a revolution in that direction means we're going to change it by 90 degrees. This much, right? So after the first move, our spinner is going to point north. Okay. Now it's going 3 3/4 revolutions counterclockwise. So in the other direction. Remember, the 3 part doesn't matter. After 3 revolutions, it'll be back to where it started. And now we need 3/4 revolutions. So it's going to go not 1/4 or 2/4, but 3/4. All the way around to here. Right? Because we're going counterclockwise now. So when that happens, the spinner is going to point east. Answer choice B. Okay, we've got midpoints of a square. Larger square has area 60. I want to know the area of the smaller square. Let's look at this visually. I'm going to draw some partitions on the square. Okay. Ooh. Okay. Let's look at this top square that I drew. This right here. That looks like a square that's been split in half. The same is true for all the other squares. Each square is being split in half, with half of it being just the outer square, the big square, and the other half has the inner square. So for each of these partitions, right, these partitions take up the entire large square. The small square is taking up half of the space in all of the partitions. So the small square has half the space. It's taking up half the space, so it's going to have half of the area. Right? You see how the smaller square takes up half the space? So in that case, our small square has half the area of the large square. Large square's area is 60. Dividing it by 2, we get 30 for the area of the large square. And that's answer choice D. Okay, we've got the letter T, formed by placing two 2-inch by 4-inch rectangles next to each other. What is the perimeter of T? Okay, so we know it's 2-inch by 4-inch rectangles. So the longer side is going to be the 4-inch and the smaller side is the 2-inch. And here we can draw the boundary between the two rectangles. Right? So let's look at the first one. Small sides are going to have area 2. Large sides have area 4. And now we're just missing something, right? We're missing here and here. Okay. Well, this entire line is on a 4 side, right? This should be 4. But we know 2 of those inches are being taken up by this, right? So 2 inches are being covered. So that means we've got 2 inches that are not being covered, right? 2 is being covered here. 2 are being not covered on the outside. So 2 in total. And because it's split in half, that would be 1 and 1. Right? So this perimeter is going to add 1 here and 1 here. So now we can find the total perimeter. Right? We've got 4 plus 4 plus 4, plus 2 plus 2 plus 2, plus 2 ones, which is 20. Answer choice C. Circle X has a radius of pi. Circle Y has a circumference of 8 pi. Circle Z has an area of 9 pi. So we want to find their largest and smallest radius. Alright, so X, Y, and Z. We already know X is radius. X has radius pi. Okay, what about Y? Well, we know Y's circumference. And how do you find the circumference? Circumference is 2 times the radius times pi. Right? That's our circumference. So in this case, Y has circumference equal to 8 pi. We can use that to solve for the radius. Right? We can cancel out the pi's. So 2 times the radius is 8. Dividing both sides by 2 to find the radius, we see the radius of the circle equals 4. Okay, so y has radius 4. Okay, finally, z has area 9 pi. So, area is radius squared times pi. In this case, it's 9 pi. Pi's cancel out, right? So radius squared equals 9. We can solve for the radius by taking the square root. Square root of 9 is 3. So z has radius 3. All right. Oh, I was supposed to write 4. Sorry. This is a 4. Okay, so let's rank these in size order. Remember, pi is roughly 3.14. So we'll use that for our definition of pi. So what's the smallest? 3, 4, or 3.14? Z is our smallest. So it's going to go Z. And then the next biggest is 3.14, so X. And then our biggest radius is Y. ZXY, that's answer choice B. So this table shows the results of a survey by radio station. What percentage of the males surveyed listened to the station? All right. So we know we've got males and females interviewed. So our total for this column should be 200, right? It says our total is 200. So we know there are a total of 96 females plus some number of males. Put M for males. Adding them together, we should get 200. So we can use that to solve for the number of males. So 200 minus 96 equals 104 males that were interviewed. So that's 104. Okay. We also know that 26 out of the 104 don't listen. So we need to figure out how many do listen. So finding the total number of males minus the ones that don't listen will tell us the ones that do listen. That would be 78 males listen to the radio. Alright, so now we need to find the percentage. So 78 out of 104 listen. What's that as a percent? I can divide both by 2. 39 out of 52 listen. As a percentage, well, 78 over 104 is pretty close to some number over 100, right? We need something that's really close to 78 over 104 because 100 is very close to 104. So our percentage is going to be close to 78, and our closest answer to 78 is E, 75. We want the product of 3 over 2 times 4 over 3 times 5 over 4 all the way to 2006 over 2005. Okay, well, right away there's something we can notice, right? It's that 3 over 2, and now we have 4 over 3. But look, there's something we can cancel out, right? We've got a 3 in the numerator and a 3 in the denominator. So whatever's left on the left top will cancel out with what's on the bottom right. Right? We can see that next we have 5 over 4, so the 4s again cancel out. After that, we would have 6 over 5, so the 5s would cancel out. So everything is going to be canceled out and then eventually we'll get to 2005 over 2004, and then 2006 over 2005, right? So our 2005s will cancel. Our 2004 will have canceled with the fraction before it. Everything else is canceling, right? And we're left with our 2, which has no other 2 next to it, and our 2006, because there won't be another 2006. So the product is going to multiply out to 2006 over 2, which is 1003, answer choice C. We want to plot the order pairs WL of positive integers. W is the width, L is the length of a rectangle with area 12. Okay. So let's look. Why don't we make some examples actually? So area 12, that just means that length times the width needs to equal 12. Right? So here we're going to have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to... Okay. So as our length gets bigger, our width is going to need to get smaller, right? Because they need to balance each other out. A bigger length is going to mean a smaller width. So already, that's going to cancel out B, D, and E. So now it's between L or A and C. So let's take a look. So if length is 1, then width is 12. Right? We already know that. And if width is 1, length is 12. So that's up here. Okay, what else do we have? Other things that multiply to 12, 2 and 6. Right? So if width is 2, length is going to be 6. That would be here. And if length is 2, width is going to be 6. That's over here. Another thing we have, so we have 1 times 12 is going to be 12, 2 times 6 is 12. Our next one is 3 times 4 is going to be 12. So 3 and 4. Here we go. So already we can see which one of those graphs looks the most similar. So we've got more of a curved shape than a straight line. So our answer would be A, right? Because C is 9, which is not what we're looking for. How many two-digit numbers have digits whose sum is a perfect square? So that means, for example, like 27. We would add up the digits in 27, 2 plus 7, and that would be 9. And that sum is a perfect square, right? Okay, what other examples are there? What other perfect squares? So we know 1 is a perfect square, that's 1 times 1. Our next one is 2 times 2, that's 4. 3 times 3 is 9. 4 times 4 is 16. And then after that is 25. Can we have a two-digit number whose digits add up to 25? Let's check. So what's our biggest two-digit number with the biggest digits? That would be 99, right? 9 plus 9 is 18. So we can't actually add up to a number that's bigger than 18. So 16 is going to be our largest possible perfect square. Okay? So what two-digit numbers are going to add up to 1? Well, there's only one example, right? That'd be 1 plus 0. So 10 is our only example. Okay, next is 4. Again, just like 1 and 0, we have 4 and 0. Then we could do 3 and 1, 2 and 2, 1 and 3. Right? We can't do 0 and 4 because 4 is a one-digit number, right? Because that's the same as just 4. Okay, what's next? We've got 9. You do 9 and 0, 8 and 1, 7 and 2, 6 and 3. I'm going to run out of room. 5 and 4, 4 and 5, 3 and 6, 2 and 7, 1 and 8. Right? Again, we can't do 0 and 9. That doesn't work. Okay, what about 16? Well, we can start with the biggest. 9 plus 7 would equal 16. Oh, shoot. Everything deleted. Okay, 9 and 7. Next one, 8 and 8. And 7 and 9. Right? We can't do any more because then we need 6 and 10. And 610 is not a two-digit number. So here are all of our two-digit numbers who sum up to make a perfect square. So we've got 1 1, 4 4s, 9 9s, and 3 16s. So our answer is 17, answer choice C. So Antoinette gets 70% on a test. on a 10 problem test, 80% on a 20 problem test, and 90% on a 30 problem test. So the 3 tests are combined into one 60 problem test. What percent is closest to her overall score? Okay, so let's figure out how many questions she's getting right. So 70% on a 10 problem test. So what's 70% of 10? Let's see. That's just 10 times 0.7, right? 70% is 0.7. 10 times 0.7, that's 7. So Antoinette got 7 points on the 10 problem test. What about 80% on a 20 problem test? Well, just like before, we can do 20 times 0.8, right? 80 is the same as 0.8, and that's 16. So Antoinette got 16 questions right on the 20 problem test. Lastly, she got 90% on a 30 problem test. So yet again, we got 30, and we can multiply that by 0.9. 90 is the same as 0.9. 30 times 9, that's 27. So she got 27 problems right on this 30 problem test. Okay, combining that, so for her 60 problem test, she'd get the 27 plus the 16 plus the 7 right. That adds up to a 50. So she'd get 50 over 60. Okay, we can simplify that to 5 over 6. So what is that closest to in a percentage? Well, we can do 5 divided by 6 to find out. How many times does 6 go into 50? 8, 48, 20, 3 is 18, and then it keeps going. So we get about 0.83%, 83%. Oh, that looks like answer choice D. Okay, Cassie is going to leave a town at 8:30, heading for another town, oh boy, on her bike. She bikes at 12 miles per hour, and then she leaves her second town at 9, heading for the first town again on... Oh, Brian is leaving the second town at 9, heading for Escanaba on his bike. And he's biking at 16 miles per hour. If they both bike on the same 62-mile route, at what time in the morning do they meet? Okay, let's see. So let's draw something out. We've got, here we'll have Escanaba, the other town will have Marquette over here. And then we've got 62 miles between them. So that's 62. Okay, we see that Cassie leaves at 8:30, and she has half an hour before Brian starts biking, not barking. So she's going at 12 miles per hour, so in half an hour, she'll go half of that. So she'll go 6 miles in half an hour. And here we can draw out some distances. Let's say that's 6, 12, 18. Okay, we'll say that those are all 6 mile gaps. 6, 12, 18, 24, 30, 36, 48, 56, 60. No, 48, sorry. 54, 60, and 62. So those are those distances. So in the first half an hour, Cassie went that distance. Okay. So now at 9 o'clock, they're going to go for an hour. Right? They've got 62 minus 6. That's 56 miles between them. And combined, Casey's going to head toward Brian at 12 miles per hour. Brian's heading towards Casey at 16 miles per hour. So combined, they're going to cover a distance of 28 miles in an hour. Okay? So after an hour, they've gone 28 miles. 56 minus 28 is going to leave us 28. So after an hour, they're still 28 miles apart. Now it's 10 o'clock. Okay? After another hour, they'll travel another 28 miles. That's minus another 28. And now they're at the same spot. So it took 2 hours after Brian started biking. Brian started biking at 9. 2 hours later is 11. Answer choice D. Jeff rotates spinners and adds the resulting numbers. What is the probability that his sum is an odd number? Alright, let's draw out a chart. Odd plus odd is even. Even plus odd is odd. Odd plus even is odd. Even plus even is even. Alright. So let's look at all of the possibilities. Well, for P, we've got two odd numbers. There's a 2 in 3 chance of odd for P, and a 1 in 3 chance for even. Okay, we know Q is going to be even, right? All those numbers are even, so Q is even, and everything on R is odd, so R is odd. We already know that even plus odd, based on our chart, that's odd. So no matter what, P is going to be added to an odd number. And, okay, let's see. If we do an odd plus an odd, that's going to be even. But if we did an even plus an odd, that would be odd. That would be an odd number. So the only way that the sum of the three spinners is odd is if P is an even number. What's the likelihood of P being an even number? We wrote it up here. It's 1 in 3. It only happens if P lands on the 2. There's a 1 in 3 chance of the sum being odd. Answer choice B. A cube with 3-inch edges is made using 27 cubes with 1-inch edges. 19 of the smaller cubes are white, 8 are black. 8 blacks are placed in the corners of the large cube. We want to know what fraction of the surface area of the large cube is white. Alright, so let's draw out our cube. We say it's got 3-inch edges. It's going to look like this. Pardon my art skills. Not an artist. That's okay. Everybody has their own strengths. Oh, yikes. That's a little confusing. I'm going to start again. Okay, here's our cube. Let's shade in what would be black. So those would be the edges. Pretend the red is black and not red. Here are all of the edges. They're being shaded red. Okay, so looking at one face of the cube, let's say the front face, we've got 4 out of the 9 quadrants, right? There's 9 quadrants. 4 of them are black. And we want to know what fraction of the surface area of the whole entire cube would be white. So looking at one face, we'd say 5/9 of it is white, 4/9 are black, right? Because 4 of the quadrants are shaded black. So the same is going to be true for all of the other faces. For all the other faces, 5/9 of the face is going to be white, and 4/9 of it is shaded black. So for the entire thing, 5/9 of it is shaded white, 4/9 is shaded black. So answer choice D is our answer.